Hello everybody and welcome to lesson 1. So here today we're going to now start just discussing the basics of Python and how we can work with it. So the first thing to understand with Python is variables. So what exactly is a variable? So a variable is a named storage of a value, really. Okay. So for example, you can remember your high school maths. So x equals 2. Okay, so now when we call x, it returns the value 2. We're essentially assigning this value to a name, okay, storing it in some sort of useful way that we can refer to it later on. Okay, we can store different types of values. So obviously here we're storing an actual integer value, but we could say name equals, and then give it a string, right? So I can store my name in name, and now name equals Corbin, right? So you'll see here that we're able to set variables by just using the equal sign, so x equals, and obviously if we set it to a different value, it now overwrites the value that we had there before. So now x is equal to 5, not 2, right? And we've lost that value, it has been overwritten. And we can also get, so we can refer to it just by calling it. If we just hit type name and hit enter, it returns what the value currently is, right? And obviously we can also use that, to do basic kind of maths things. So for example, let's store y equals 2. So now we have x, we have y, but we can also do x plus y, and it will return 7, because in this function over here, x is equal to 5, y is equal to 2, so it calls both of them, then does the sum, and then returns that. Okay, so very, very basic. It's just storing values with a name, essentially, so we can refer to it. Okay, then the other main part of any code really is functions. So what is a function? A function is basically an action, or it's a snippet of code that we run to do something, to perform some sort of action on our code, to maybe alter variables or to do something else in our Houdini scene. So functions take arguments, right? So let's say I were to tell you, okay, to jump. Okay, so jump would be an action. It's essentially a function. I'm telling you, please jump. Okay, so all functions have brackets at the end here. Okay, so they got parentheses, just the round parentheses. So when you see something like this, it shows you that is a function. And sometimes the parentheses can be empty, because some functions take no arguments, so that is possible. But normally they will take at least one argument, or sometimes multiple. So for example, if I tell you to jump, you might ask me how high, right? I need to give you more information for you to be able to perform this thing properly. So this is actually what the function would look like then. Okay, so the function is jump, but it needs some information, so it's going to ask you for that information. So the inside of the brackets, you'll have a list of all the arguments you need. So I'll say jump, and then it's got height. So to run this function properly, you would then need to, and obviously don't worry about this, it's going to error out because jump is not an actual function in Houdini. But, for our purposes, we would say jump, and I'd say 1 meter high, and then you'd jump by 1 meter, right? And there can also be multiple arguments. So I'd say run, and then, so you say, okay, well, how fast should I be running? And also, how long should I run for? Because you need to know those two things in order to be able to actually run and then stop at a new location. Okay? Because if I tell you how fast to run, but not how long to run for, then you're just going to keep running and keep running. And there's no way for you to then tell me your new location if I don't give you these two variables. Okay, so these two arguments help this function actually perform what it needs to do. All right. So let's use an example. So I want you to see that basically some functions, they can do something in your scene. They'll perform some sort of function, or maybe create something, create a folder, create a node, or whatever. So they can do things, but also some of them return a value. Like I was talking about here with this run function, essentially you would have a location. Okay, it's almost like your points in your scene. They've got a point position, right? But if you tell it to move by a certain speed and then for a certain number of frames and then stop, it can then tell you its new location. So what it's doing is it's actually returning new information. So we're going to use a function here. Let's use one that actually exists now. So absolute, right? So ABS, absolute, which is just going to return the absolute of a number, which means no negatives. So -5 should be 5, but 5 will also return 5. So positive or negative, you feed it and it will return only positive. Okay. So let's say we're using here, so let's give it -2, right? So it wants one argument, and you can see here it's telling us that it wants one argument, which has a keyword called number, okay? And what it's going to return, see this little arrow is showing what it's going to return, and it's going to return a new number, right? So we feed it -2, and then it returns 2, okay? We could also feed it +7, and it will return 7. Okay, so you see it's performing a function and returning a new value. But how do I now get this 2? Okay, because I've now run the function again here like this. I've lost this value. I can't access that. Okay, because I haven't stored it anywhere, and that's the purpose of these variables that we spoke about. Okay. The reason we want to be able to store information is because we're going to run a function. It's going to return that value, and we need to store that value somewhere that we can access later on in our script. I have no way of currently accessing this number 2, but if I said x equals absolute, and let's say -8, okay, now you'll see it didn't actually print anything, because it only really prints when it has nowhere to store that information. So it just kind of defaults to printing it. But now, it didn't print, but when we go x, it now returns 8. Okay. And so throughout the rest of our code, as we start typing a whole, complex lines of code, we can refer to this value by calling x. Okay. Now, there is one more thing I want to talk about in this lesson just before we really get into the nitty-gritty of how to work with Python. So we understand variables, we understand functions, but object-oriented programming is a term that you're going to come across if you had to sort of research Python. I mean, if you just Google what Python is, it's going to come up telling you that it's object-oriented programming. But what does that even mean for us? So what's important with Python to understand is that basically every data type and every instance of a data type is its own object. Now don't get confused by that. I am going to explain, but just basically know that we're trying to separate or group like things together. Okay, so for example, if I said to you, right, let's go back to our jump function. Okay, so I say jump, and I say one meter, but I apply this function to a cup. So I tell the cup on my desk to jump by 1 meter. That makes no sense. That is, I mean, a cup can't jump. So why should we be able to access this jump function across everything in our scene? Doesn't really make sense. It needs to then error. It needs to figure out, okay, well, hang on, but cups can't jump, and what do I do? It's very complicated, right? So it makes much more sense to store these variables and functions inside of actual objects, right? So each data type. So in this example, a cup is a data type, right? So actually, technically, cup itself, the idea of a cup is called a class, but then a cup, like literally my cup. You know, the cup on my desk, not the cup on your desk, is an instance. And then the one on your desk is its own instance. So they're essentially all copies of the global idea. So the global idea is called a class. The individual cups that are actually made are called instances, right? So you won't be able to run this, you know, cup jump function, but a human can jump, right? So you are able to actually tell a human to jump, and then tell them, you know, jump by 1 meter, right? So, but and then also don't forget that variables are also stored in these objects as well. You know, a cup, for example, can have a weight. You know, so the cup's weight will be equal to something. Okay, you know, obviously a very small amount, but you know, a cup will weigh something, and a human can also weigh something, right? Sorry if I could spell it. You know, and then a human weighs something, obviously significantly more than a cup, unless it's a giant cup. But a human has a name, while a cup does not. I mean, unless you name your cups, but yeah. So basically what I'm saying is there are functions that make sense within an object, or an object type, okay, a data type, and there are variables that only make sense within certain data types and not others, okay? And so how Python works, and essentially what object-oriented programming is that you have to refer to the human first, you know, so we would say, you know, that x equals, and then we would refer to a human. Now here I'm just putting it as a string so that it doesn't error, but you know, we would essentially refer to a human and store it in a variable, okay? And then you can refer to that human, you then with a dot, okay, which is to sort of run a function, you put a dot, and then jump will appear in this list of functions that we have available because x is a human. Whereas if x was a cup, when we hit dot and this list of functions appears, jump would not be available. It is not an option because we're referring to a data type that does not have jump as a function, okay? Because here we are, so let's say we refer to x, which is our human, and we say dot, and then maybe we run a function called pick up, okay? Because humans can pick things up. So we say x, pick something up. But it wants to know what we want to pick up, right? So this is exactly like in real life. If I say to you, pick that up, and you go, pick what up? You know, I have to tell you what to pick up. So then I say, okay, well, pick up the cup. Okay, so the argument that I need to give you in this variable, in this function, is the cup. I need to give you information so that you can perform this function correctly. Okay, and then what you're going to do, once you've picked up that cup, now you're holding that cup. You can do something with it. So essentially, this function has returned something. It has returned a new object. Essentially, it has returned an instance of a cup, right? So we could then store that in y. So we would say y equals, and then x pick up cup, and it would return an instance of the cup for us, okay? Now, again, if I hit enter, it's obviously going to error out because these are just made up functions. But, you know, let's just say that y was now equal to a cup, okay? So we go x is a human, y is a cup. Okay, cool, you know, because we asked you to pick up a cup, so now we've been able to return and store that value, right? And now, because, you know, you have these two variables basically, we can say now x drink, okay? So I need to tell you to drink something, but you also then need to know, well, drink from what, you know, because maybe there's another mug on the desk, there's a jug somewhere, so you know, like, okay, we'll drink what? So I'll say drink from y. In other words, drink from that cup, okay? So I'm telling you, the human, to perform a function, but you still need another object as an argument to this function, okay? And then when this function is run, instead of it returning something, okay, when we run this, okay, again, ignore the error, but what it would do, if this was a real function, would return nothing. Because I told you to drink something. I didn't tell you to give me more information or do something different, or do something to me or for me. I just asked you to drink from the cup. So what has changed is the variable that is stored within the cup. Okay, so the cup has what's called a property, which is its basically the volume. Okay, so like how much liquid is in this cup. And before, the cup's volume would have been, let's say, 100%. Okay. After running this x.drinky function, what has changed, what this function will alter, is the volume value of y. So now it'll be equal to maybe 50%. Okay, which means you've now drunk half of what's in the cup. And then if I perform this function again, it will then say 0. And if I perform it a third time, then something else will happen. Like you will have to return some error saying, hey, I can't drink from this cup, it's empty. Okay. So I know this is a little bit of a convoluted example, but really what I'm trying to get across to you is to understand how Python works, how it thinks. Okay. We have these individual objects, and depending on what type of object it is, it can do certain things, and it has certain properties. Okay, so the things that it can do, those functions, are called methods. So inside of an object, a function is called a method. And the variables that we're storing, like volume, is a property. Okay, so that cup has a volume, it has a color, it has a weight, it has all of these properties, and it can do certain things, but it cannot do others. It can't jump, but it can be drunk from. It can smash. Okay, so this is how object-oriented programming works. And what it does is it essentially groups together functions that make sense, right? It would be very confusing if we could run, we've got a cup and then we hit dot and in the list there is jump. And then we try to run jump, but then it errors. In this way, what it does is it only gives us things that can actually be performed on these objects, which helps keep it neater, helps everything make sense. Okay, so if that explanation didn't clear anything up, don't worry. Maybe once we get going and get coding, you can keep coming back to this, and one day it'll click into place, because it took me a while to sort of figure out, this how this object-oriented programming was useful to me, until I actually understood what it was doing, and then suddenly now the whole of Python made a lot more sense, which is why I wanted to share this example with you, but it may not make sense at first. So maybe return to this later and one day it'll pay off. All right, so thank you everybody, and I'll see you in the next lesson.